forces of nature.
Yeah.
So in what areas? What are you looking at?
Well, the idea is that if you look at the world that we see, so you know, the green leaves, the blue sky, spherical planets, all those things are telling you something about the deeper structure that underlies nature. So even life. So next week's is about the origin of life. So it's how did we feel living is a very special thing, but it's a property of matter, of this stuff. The Earth was once just a dead world when it formed, 4.5 billion years ago, and at some point that matter came alive.
And you go to some really far-flung destinations, and as you can see there from that tiny bit that we showed, I mean, it's beautiful. Like, it's beautifully shot, and you see some incredible things that you wouldn't necessarily have to get to see.
Yeah, I think that was the idea, to send film crews out, and it's sort of the way you mentioned David Attenborough earlier, the way that his programmes work, where a film crew can go and for months even film something spectacular. And we saw that wave on that clip through the Amazon.
Yeah.
It's a wonderful, incredible tidal wave that goes up the river, and you see in the film that someone spends their life surfing it. So there's kind of his whole thing is to wait for this wave and surf into the jungle of the Amazon.
How often does it come along?
It comes when the moon and the sun are aligned. So I think it's about once every couple of months or something like that. The Pororoca is called.
Well, you're not, because they go out and they sit for months waiting for something to happen, the right thing to happen. You're not there all the time. You're in this one less, aren't you?
Yeah, I mean that was the idea, to film these beautiful things. You can't, if I'm there, it's kind of, you can't spend all that time. We had different crews out at the same time filming things, and then the idea was to try and stitch it together. Essentially, you ask the question, what is it? What's the biggest, the tallest mountain you could make on a planet like the Earth? What sets that? So you've got the Earth's gravity, which depends on its mass, really, how much stuff is in the Earth. It's pulling it down, pulling it down. So you can imagine there's a force on the ground, and the bigger you build the thing, the more the force is. And you can work out, well, what is it when that force overwhelms the strength of the rock and it starts to sink? And it's actually on Earth, the mountain Mauna Kea, which is one of the Hawaiian volcanoes. It's actually taller than Everest, if you measure from the surface of the seafloor, and that's sinking. So that's as tall as it can get.
The mountain's sinking.
Yeah, so it's too heavy.
So that is as tall as they go.
Yeah.
They could go here.
So if you've got a big enough planet with enough gravity, essentially, then anything that gets too big will sink. And gravity just works in it. It doesn't care which angle you're at. So it
pushes it back
into a circle, to a sphere, if it's big enough. And then you look out into the solar system, little moons, less than about 150 miles across or something like that, have not got enough gravity, so they're all misshapen. It's called the potato radius. So you get potato shape.
I can say that one.
But the potato radius.
Show us with
Oh yeah. So well, the way that I demonstrated it, you just wanted to get messy, don't you?
Of course we did.
So the way that we demonstrated it in the programme is say, so what am I doing? If I want to make that into a ball, then I have to apply enough force to overcome the... If I don't apply enough force, then it'll stay like some sort of misshaped, potato shape. So that's what gravity is doing, really. It's acting as a force that's squashing it down, and it'll turn it into a sphere because it acts the same in every direction.